We're going to be talking about Linux Kernel Hardening. This is like, the second part of the presentation I gave yesterday. We ended up the presentation yesterday about talking about the efforts on enabling the Wflex-array-member-not-at-end compiler option in the Upstream Linux kernel. So the presentation today is going to be all about the strategies I've been following to address this issue in the Linux kernel. So, yeah, well, I have to say that my work in the Linux kernel community has always been supported by the Linux Foundation, and over the past few years, also by the Alpha Omega project, which is a project funded by Google, Microsoft, and AWS. So thanks to those organizations for supporting my work in the kernel community. Okay, just real quick, a couple of words about me. I've been doing Linux kernel hardening or proactive security over the past 9 years. I am a member of the Linux Kernel Self-Protection Project, which is basically the Linux kernel division of the Google open source security team. However, I am not a Google employee. So the agenda for today, we're going to quickly review something about flexible array members. We're going to get, after that, we're going to get into the weeds, so how it is that we, what are the things that we are doing to enable this compiler option, Wflex-array-member-not-at-end, in the Upstream Linux kernel. What is wrong with having flexible array members in the middle, and well, at the end, some conclusions. Okay, this is just as a reminder, or well, for people that couldn't attend my presentation yesterday, I have to say that when we need to use a flexible array member in a structure, one of the requirements is that this object has to be the last member of any containing structure, right? Another important thing to keep in mind, and that is going to be crucial for this presentation in particular, is that an instance of a flexible structure may not be a member of another structure, right? So this is what the C language says. And usually, when we need to implement a flexible structure, we need to include, or it is recommended to include a counter member. We are going to use this variable to hold the total number of items or elements our flexible array member is going to contain at some point at runtime. And of course, in recent times, we've been annotating every single instance of a flexible array member in the Linux kernel with the counted by attribute. And this attribute brings runtimes by checking coverage on flexible array members. And well, this is a link to a blog post I wrote the last year. You want to know more about this attribute? Just take a look. Okay, this compiler option was developed by Xin Zhao back in 2023. She's a crucial member of the Kernel Self-Protection Project. She's been doing basically most of the things we've been using in the kernel to harden the Linux kernel over the past 6 years have been implemented by Xin in the GCC compiler. At the bottom, you can see a link to basically all of the work she has been doing to help us with this task. Okay, so now this compiler option is going to warn when we have a flexible array member in the middle. So what we have here is we have an instance of a flexible structure in the middle of a composite structure. So that is a warning. That is basically what this compiler option does. It detects these issues. A simple way to fix this is just merely move that middle member to the end of the composite structure, and we can even change its name, so we can make it very explicit that now is the last member. And with this simple change, that warning goes away. However, if we have an instance of a composite structure in the middle of another structure, that is going to be a warning again. So and so on and so on. So this is an issue. This is a problem. Now, what is wrong with having flexible array members in the middle? First, let me say that a flexible structure in a composite structure is an extension to the language. This is not part of the language. And as an extension, it can be an instance of a flexible structure. It can be either the last member or not the last member in any containing structure. So this part is deprecated now. This is what we want to remove from the Linux kernel. Instances of this code is not welcome anymore in the kernel. So basically, this is what the compiler people says, particularly GCC people, about this kind of code. Is compilers have issues when they try to determine the sizes of objects that contain this kind of code. So basically, as we may remember that one of the requirements to use a flexible array member is that it should be the last member in any containing structure. So all of a sudden, it doesn't really make sense that we can have instances of flexible structure in the middle of other structures, right? So we want to avoid the issue of allocating heap space for the flexible array in the middle and unintentionally overriding the following adjacent members, right? However, as we are about to see, that is a common pattern in the Linux kernel. People do that intentionally. People have flexible array members in the middle, and they override the following adjacent members. So as we're about to see, I've been implementing some strategies to allow for this in a controlled manner. So yeah, we can still do this as long as those members are at the end, are moved at the end of any composite structure. So we are going to get into all the details later on. So the first time that I built the kernel with this compiler option enabled, I ran into 60,000 of these warnings. However, I was curious and I wanted to see how many of these issues we had before starting the world of flexible array transformations, the word that I was talking about yesterday. So it turns out that we had 8,000 of these warnings, right? And now, after 6 years of hard work hardening the Linux kernel, we have a lot more, right? So this is indicative that at the time, back in the day, when we only had 8,000 of these warnings, we didn't really know all the problems and all the issues we were going to find later on, right? So now, the good thing about this is that now we are aware of all the things that we need to fix and all the different ways in which we need to rearrange a lot of the code in the Linux kernel to still allow for these flexible arrays in the middle in some way, but in a more controlled manner. Fortunately, while I was reviewing, classifying this, trying to identify patterns in these 60,000 warnings, I realized that only about 1% of those are unique issues. And well, the reason why we have thousands of these warnings, that 60,000 of these warnings come out of just 1% of unique issues is because it might well be the case, and it is the case, that a couple of those or a dozen of those unique issues are included in headers, and those headers are included in hundreds of C files or other headers, right? So that's the reason why this multiplies. Then after going through hundreds of those unique issues, I managed to classify them into at least 4 main categories. So we're about to explore and to go into details about each one of these categories. So my intention here is that you have a clear idea of how it is that we are trying to address this problem in the Linux kernel. And also, if you also work on, I don't know, if you are embedded software engineers or you have your own C projects and you want to have this option enabled in your own project, well, you can basically take this as a guide to how to start addressing this problem. So the first case is the most simple one. In this case, the flexible array member is never going to be used, right? So, and the reason why this flexible array member exists in the code might be because originally the people that introduced it to the code base, they probably used it at some time, but after some changes and given to the to how the Linux kernel evolves over time, this might well be just leftover code, right? So someone just forgot to remove it from the code base. So in this case, well, no heap space is allocated for this object, so we can just simply remove it from the Linux kernel, and that's the most simple change, right? This is just part of the commit I submitted to address this issue. I found like 4 of these instances in the Linux kernel, and by removing all those 4 instances, I managed to fix 100 of those unique Wflex-array-member-not-at-end warnings. So that was a great thing. And in the beginning, I thought that this was going to be a very simple task. I was like, yeah, I mean, probably some people just forgot to remove this array, so I'm going to just find them and remove them, right? But as we're about to see, this is not the case at all. Okay, now case number 2 is when the flexible array member is, there might be some instances of code where people are allocating heap space for the flexible array member, but that never happens when it comes to the composite structure, right? So in the composite structure, at least in the kernel code, I never found an instance where the flexible array member was referenced through the composite, by the composite structure through the middle object in the composite structure. So something like this never happened. It might well be the case that people may access the other members in the flexible structure, like in this case, A and B, which are the header part of the flexible structure, but they never access the flexible array member. So the question is, okay, so what can we do in this case? We cannot simply remove the flexible array member as in case number 1 because it is used by other instances of code, right? So one solution could be probably we can just create a new structure. In this case, struct-flex would be that new structure. And in that new structure, we can include the header part of the flexible structure, and just and of course we are not including the flexible array member. So if we do this, now we can simply replace the type, the conflicting type, from the type of the flexible structure to the newly created type, and this new type doesn't contain the flexible array member. So that would be a very simple fix, because now we're getting rid of the flexible array member. We are leaving the flexible array member out of the equation, right? And life is beautiful. Okay, so but what is the problem with this kind of solution? Well, the thing is that we are duplicating code, right? Unnecessarily. We are basically creating a completely separate new structure and duplicating the header part of the flexible structure, and that really is not ideal, because that means that maintainers will have to maintain duplicated code, right? And if they need to implement some new changes to the struct-flex, they also need to remember to add those changes to the newly created type. So that really is not a good solution. So the next thing that we can do is probably instead of duplicating the members, or instead of maintaining those duplicated members in the flexible structure, we can just create an instance of that newly created type, and we replace the header part of the flexible structure with an instance to the newly created type, right? In this way, if we need to update the flexible structure, well, or the header part of the flexible structure, we just have to update one structure, not two. Okay, but one of the requirements to use counted by right now is that the counter member, in this case count, cannot be in a non-anonymous structure. So something like this is not possible right now. So this is not supported yet, but this is coming. This is something that is going to be available in the next version of GCC. Right now we are in the version 15, and in GCC 16 this is going to be available. However, right now we cannot do this. So a solution for this is to use the struct group helper. So yesterday we were reviewing a little bit about the internals of this helper, and I was saying that this is a family of helpers. So in this case, we are going to use struct group tag, and I'm going to explain how this works. So what we're going to do is, instead of creating a newly separated type, we are going to enclose the header part of the flexible structure with the help of struct group. And this flex header, this is a tag that we need to pass to struct group. So internally, what is going to happen is that struct group is going to create a new struct type. And when struct group creates that new struct type, then we can do the same thing that we were doing in the past example. We can just replace the type from struct flex to struct flex header. And with that, the flexible array member is out of the equation. We are not duplicating code, and we don't have the problem with counted by. Okay, now let's review the internals of struct group tag. So thanks to we have an anonymous union, and within that anonymous union, we're going to have an anonymous structure. And thanks to that anonymous structure is that we can still access any member enclosed in struct group directly. And we don't have to go through an identifier, right? So we don't have code churn in that case. Then we are creating, this is a tag, and with that tag, we are creating that new struct type. And that new struct type is the one that we are going to use to replace struct flex in the composite structure. So this is basically the magic behind struct group tag. And we can also gain bounce checking on the whole group if we need it. So if you remember yesterday, or for people that didn't attend the presentation yesterday, a struct group also uses a new identifier for the whole new group. So through that identifier, we can access each of these members, but we can also access them directly, as I was saying, right? So this is part of a patch I wrote a while ago to fix one of these problems. Here you can see that I am enclosing the header part of a flexible structure with struct group. In this case, we are not using struct group tag because if you notice, this structure has the packed attribute. And when we need to use attributes, we can use this other helper, this struct group helper. So that's the reason why I'm not using struct tag here. However, this helper also includes the same functionality as struct group tag. So we also have here, we are going to create the new a new struct type because this is a tag. And here in this code, we can see how now I am replacing, this is the type of the flexible structure, the ones that contains the flexible array member. And I am replacing now that type with the newly created type, which is the one that doesn't contain the flexible array member. And with that one goes away. And this is a sensible fix because we are sure that this composite structure will never use the flexible array member. Okay, now the case number 3 is probably the most complicated one. So let's get into this. For case number 3, what we have here, what I noticed is that people, they wanted to have an implicit union between a flexible array member in the middle. Here we have an instance of a flexible structure, and of course, the previous member before this fixed size array is going to be this flexible array. And if you notice, the fixed size array is of the same element type as the flexible array member. So that is intentional. People really wanted to implement this kind of code to write data or to pre-allocate space for the flexible array, right, at compile time. However, in the best scenario, these two arrays are going to start at the same memory address, and that is the intention. That is the idea. However, this is probably not going to be the case all the time, because if people modify the flexible structure, Or if people modify the composite structure, the alignment of the structures are going to change. So if people modify the composite structure, it might well be the case that there is going to be some padding between the instance of the flexible structure and the fixed size array. And it's also the case that if they modify the flexible structure, they might create some trailing padding at the end of this flexible structure. So that is going to create some misalignment between these two arrays. And that is going to be an issue. And I have found a couple of cases where I run into a couple of issues, and I reported them. And yeah, in fact, that wasn't intentional, right? It wasn't intentional to have some padding between these two arrays, between the star address of these two arrays. So in those cases, people would need to use some static assert after the composite structure just to make sure that the offset of the flexible array, of the star of the flexible array, is exactly the same as the offset of the star of the fixed size array. And now, let's get into trailing padding. So I'm going to give you a clear example so you can understand what I'm talking about. Okay, so what we have here, we have, at the bottom, we have a flexible structure. And at the top, we have a flexible structure, and at the bottom, you can see that we have an instance of that flexible structure, and immediately after that instance, we have a fixed size array, right? A fixed size array of the same element type of our flexible array member. Okay, now, the offset of the flexible array member is going to be 3, right? This is the offset column. This is the size of the objects, right? So the offset is going to be 3. However, the size of the flexible structure is 4 because we have padding. This padding is trailing padding. This padding is something that is added after the flexible structure, right? And this is even more explicit in this case. By the way, this is pay-hole output. If you don't know, pay-hole is the poke a hole tool we use in the Linux kernel all the time to read the layouts of structures. And here in the composite structure, it is clear that we have 1 byte of padding between an instance of a flexible structure and the fixed size array, right? And if you notice, the offset, the star of this instance is 80, is the offset of this instance. And if the offset is 80, the offset of the flexible array member from this point of view is going to be 83, right? However, the offset, the star of the fixed size array is 84. So that's the issue, right? There is a difference there, and that's misalignment. And well, I submitted a patch. If you want to know all the details about this particular case, just this hyperlink here, and you can check it out. So that's a big problem with these kinds of with flexible array members in the middle. Again, is the case that I was talking about yesterday. People can do whatever they want, and they can say that they know what they are doing until they don't, right? And that is the problem that we are trying to address, that last part. Okay, now let me show you a kernel example, another kernel code example of this case. So what we have here is, again, we have, if you notice, on this side, we have a composite structure. This is an instance of a flexible structure that contains a flexible array member. And we have a fixed size array of the same element type of the flexible array member. So there is an implicit union here, right? So the solution here is to create, of course, enclose the header part of the flexible structure with the help of struct group. We need to include the path attribute. And of course, now we replace the type of the flexible structure with the type of the struct group, right? However, in this case, the rest of the code in the kernel, they were accessing diets, right? They were trying to access diets through an instance of a flexible structure. So let me show you how this looks. What we have here is this is another part of the code. This diets is the flexible array member. However, when we implement this change, when we change the type, that dies is no longer there, right? Because that's the idea. We don't want the flexible array member. So this is not possible. We need to find a solution for this. We need to modify this code to allow this main copy to access the flexible array member that right now isn't there. Okay, so how can we do this? We can use container of. If we use container of, we are going to get a pointer to the flexible structure, and through that pointer, we can access the flexible array member that we had previously left out of the equation. So that's the trick. So this is how this works. We need to create a new variable of the type of the flexible structure, and of course, container of. We're going to pass. For those who don't know how container of works, it's a cast but a controlled cast, right? So what we're going to do is we're going to pass a pointer to a member, and we are asking, okay, I'm going to pass you a pointer to this member. I'm going to pass you the name of this member and also the structure that contains this member. So just give me the pointer to the beginning of that containing structure, right? So this is what is going on here. So in this line, we are getting a pointer to the flexible structure, and then we can access the flexible array member. So we remove this line, or rather, we modify this line, and we can access, and now we can access the flexible array member, right? So that would be the trick. First, we get rid of the flexible array member so that the compiler doesn't complain about it when it reads the flexible, the composite structure, or when it compiles the composite structure, and then we have to modify any code that actually wants to access the flexible array member. And well, that will be the complete patch. I mean, there are a lot more changes, but for the purpose of the presentation and just to explain this case, this is enough. Here we are passing the pointer to the header to the header member that now is of the type of the newly created type within struct-flex. And then we are getting the pointer to struct-flex, right? And that's how we access the flexible array member. And that's if you want to take a look at the whole commit, you can access that. This is a hyperlink. Okay, now let's explore case number 4. I mean, I'm getting out of time, or are we running out of time or something? More or less, right? We have like 10 minutes, I think. Okay, let me go quickly with this. The case number 4 is the same case. It's an implicit union. However, in this case, it's on stack. So it's exactly the same case. We have a flexible structure, and we have on stack, we have an instance of that flexible structure, and the following adjacent member is a fixed size array of the same element type as the flexible array member. This is kernel code, and the way in which we can fix this is through the use of another helper, which is define Wflex. And define Wflex, we can basically, one of the arguments is the type of the flexible structure. We pass define Wflex creates a pointer, so we need to pass an identifier for that pointer. We need to pass the flexible array member and the number of elements that we want to allocate on stack for the flexible array member, right? So in this case, we know that this type is of the same element type as the flexible array member, and originally the code wants 2 elements of that, or two items of that type. So that's the reason why we're passing 2 here. And then we just need to, initialize the members. Okay, so here are some examples of how I was addressing these issues. We can use either declare Wflex or declare flex. Okay, another case is when the following adjacent member is not of the same element type as the flexible array. In this case, the following adjacent member is actually a union. And of course, that's different of an integer of size 8 bits. So what we can do in this case is we still can use define reflex, but we need to determine the maximum size of those structures within the union, right? So we can allocate enough space for the flexible array member on stack. So we need to use the max macro just to get the maximum number of bytes from each of those structures. And that is a partial road, and if you want to take a look, there is a hyperlink there. Another case is similar to the last case. However, the union now has more members, right? Rather than 2, the union has now 3 members. So what I did at the time was instead, I could also try to fix this by nesting a couple of max, but that was very ugly. I didn't like it. What I did at the time was instead I created a new union type, and then I just applied the size of operator to the union, and we are going to get the maximum number of bytes to allocate for the flexible array member. Then when I did that, the maintainer replied, and he actually suggested what I was trying to avoid, right? He was like, well, instead of creating a new union type, why don't we do something like this? And at that time, I was like, oh no, this is a bit too much, and probably we are not using the define reflex as it is intended to be used. And I'm actually writing a blog post explaining this, and because doing this is too much for me, and this is basically abusing this helper. So define reflex was not really created for this scenario. And well, what I did at the time was create a new trailing, a new helper, in this case, trailing overlap. Trailing overlap, we have a union, and we have some tricks with trailing overlap. We actually created, including the type, the flexible structure, and we create an offset to displace the start of the first member of the first following adjacent member to start at the same address of the flexible array member. So this is the open-coded trailing overlap. As you can see, this is the offset that displays the star of the flexible array member to the start of the first member in the following in the union. And this code basically looks like this, right? So this would be the solution. Instead of using define reflex, we can use trailing overlap. And well, yeah, this looks like this now. It's much better. Okay, I'm running out of time, so I'm going to just run over the slides. Okay, so this case is superior to the use of struct group and container of. So all these changes translates to these couple lines of code. So it's cleaner. This solution is cleaner, right? Okay, so now the evolution of these approaches. First, I was trying to use separate structures. That didn't fly for the reasons I explained. Then I implemented this technique with struct group and container of. That works in some cases. Then for issues on stack, we can use these helpers, define flex, define reflex. And lastly, we can use trailing overlap. So this, you can take a look at this hyperlink, and this example is great to me because this is basically the whole evolution of the different strategies I've been trying to implement in one single patch. So you can see basically my reasoning process here up to the point that I created trailing overlap. Some conclusions, well, we have a three-step approach for the complex case. We can use struct group tab, and we use container of, and with container of, we can access the flexible array member. However, in many cases, it is better to use trailing overlap. For these problems on stack, we can use declare reflex or declare flex. Declare flex is going to be used when we have annotated the flexible array member with the counted by attribute. And for all other cases, just use trailing overlap. So I have a clear strategy how to complete this work. I started with 650 of these warnings. Now I'm down to 200, so basically 60% of the total warnings have been fixed so far. I have to repeat that the vast majority of those issues are false positives, but I have found some legitimate bugs. And that's it. Thank you.